Hello class, in this video I'll be showing you another example on how conditional probability can be used to determine the probability of the intersection of two events. Let's begin. A bicycle factory runs two assembly lines, A and B. If 95% of line A's products pass inspection, while only 85% of line B's products pass inspection, and 60% of factory's bikes come off of assembly line A, find the probability that one of the factory's bikes did not pass inspection and came off of the following. And we will start with assembly line A. All right, so in the middle, I have a tree diagram. And the first branch represents the assembly line the bikes came from. So event F represents the bikes came off of assembly line A, and the branch over here that's highlighted in green represents the bikes came off of assembly line B, and that will be F's complement. All right, after the first two branches, there are two more branches for each. And notice the first branch after A does not pass inspection. And I've labeled that E, which means passing inspection is E's complement. And on the bottom branch, if it comes off of assembly line B, it either does not pass inspection, which I labeled E again, or it does pass inspection, which I labeled E's complement. All right, so I want to find the probability that the bike came from assembly line A and did not pass inspection. So that would be the probability of F times the probability of E given F has already occurred. So if let's take a look at the tree diagram here. All right, let's fill in the branch. So the branch that's in blue, that's going to represent the probability that the bike came from assembly line A. So in this case, it looks like that's going to be 60%. So I'm going to write 0.6 in that top branch. And that means 40% came from assembly line B. All right, so those bikes that came off of assembly line A, how many of them passed inspection? Well, it looks like 95% of line A's products passed inspection. So I'm going to write 0.95 on the branch for passing, and then 0.05 for the branch that represents does not pass. And now we are ready to answer the question. So the probability that the bike came from assembly line A is 0.6, and the probability that it did not pass inspection given that it came from assembly line A is 0.05. So this probability is 0.03. Okay, now let's find the probability that one of the factory's bikes did not pass inspection and came off of assembly line B. All right, so we already have the percentage of bikes that come off of assembly line B, that is 40%. So now we have to figure out how many of those does not pass inspection. So we know that 85% do pass inspection. So I'm going to write 0.85 in the fourth branch, which means 15% of those bikes do not pass inspection. So we were trying to find the probability of F's complement and E, which will be the probability of F's complement times the probability of E given F's complement. Or in other words, it's the probability, I'll highlight it, the probability that the bike came from assembly line B times the probability that the bike did not pass inspection given it came from assembly line B. All right, so this is going to equal 0.4 times 0.15. And that is going to equal 0.06. Okay. Find the probability that one of the factory's bikes did not pass inspection. Okay, so the bike can only come from two assembly lines. It can either come from assembly line A or assembly line B. So either the bike came from A or B. So that means I want the probability of F and E plus the probability of F's complement and E. So this would be 0.03 plus 0.06. So this probability is 0.09. And we are done.